So let's again go back from the polynomials. Why? Because whenever we talk about quadratic equations, first we must know what is a polynomial. Before that, we must know what is a variable, what is a constant, how a polynomial is formed, and then we will interlink with quadratic equations. Then how to find the roots of a quadratic equation, sum of the roots, product of the roots, and after that nature of the roots, blah blah blah. Okay, next it continues. So, but to discuss about a quadratic equation, so first we need to understand about a polynomial. Okay, fine. So once again, maybe you all know that, but maybe for one or two people, I have to teach what is a polynomial or how a polynomial is defined and all. Then we will come back to our chapter name, that is quadratic equations. Fine. Hope you all know about variable. Before that, constant. Fine. So constant. Yeah, can someone just raise your hand with your confirmation? Is my voice is clear for everyone? Just one of you raise your hand or say yes. That is enough. Yeah, fine. That's good. Fine. Thank you, Shrestha. Thank you, Amma. Okay, fine. So constant. Let us talk about constant first. Okay, fine. So constant. It is nothing but it is a fixed value. The name itself says that it is a constant. We cannot change it. So it is a fixed value. It is a fixed value. Once again, of course, you all know this, but still I have to teach. Okay, don't mind. Fine. So for example, 3. Yeah, in every problem or in every chapter, it remains 3 only. Maybe minus 1 by 3, maybe 0. All this. Okay, you take natural numbers, whole numbers, or fractions, decimals, rational, irrational, whichever the number you take. So it remains as it is only. So those are all numbers are called as constants. It is a fixed value. For example, 0, minus 1 by 3, or yeah, even if you take root 3, okay, fine, or minus 3 by 5. And all these numbers are called as constants as they are fixed, or they have a fixed value for them. Fine. Then next, we need to talk about variable. Variable. It has derived from the term varying. Varying is nothing but changing. The meaning of varying is nothing but changing. So the value of which keep varying. The value of which keep varying or changing. The another meaning of varying is changing. So for example, you might have solved number of problems as of now. So in one problem, you might have observed maybe finding x value, suppose say. Okay. So in x value, maybe in one case, you might have got x equal to 1 by 2. Or in another case, you might have got x equal to 0. Or in another case, you might have got x is equal to 3 by 5. So here, from the case to case or situation to situation, the value of x is keep on changing. So here x is called variable as it is varies its value. Okay. So like that, you take any alphabet, or rather I can say variables are denoted by or represented by alphabets. Fine. So here I can write x is the variable. Here x is the variable. Fine. And all the variables are represented by alphabets. Fine. Next, we need to talk about a term. How a term is obtained or generated. So we have discussed what is a constant and what is a variable. So if constant and variables are grouped by the help of either multiplication or division. Okay, so if the variable and a constant is grouped or combined, I can say, with the help of multiplication or division. So I'll write here, or we'll write in shortcut. Terms are obtained. Terms are, anyway, you all know this, right? Fine. Terms are obtained either by multiplication, I'll just try shortcut children, or division of variable and constant. Variable and constant. Fine. Let us observe some examples. So let us take some variable x and multiplied by some constant, maybe 3 by 5. So which is 3x by 5. So 3x by 5 is a term. Okay, you can ask me, so what if I take only variable? Suppose if I take p, or what if I take only the constant? Yes, no doubt at all. We can write here some 1, right? P into 1 gives you p. So hence the variable alone is also called as a term. And here also we can write 3 by 5 as x for 0. Why? Because anything for 0 is 1. So we can again rewrite it as 3 by 5 into 1, which gives you 3 by 5. So constant alone is also called as a term. So clearly a term is nothing but constant alone, or variable alone, or product or division. I mean to say multiplication or division of both variable and constant. Fine. Then next we need to talk about algebraic expression. Algebraic expression.
Sir,
Yeah. Yes, Mana, tell me.
can you show the notes of constant?
Constant. Yeah, I'll show. Can you please make it, take a screenshot if not? Why? Because we are almost done with term also.
Okay, thank you, sir.
Yeah, thank you, Amma. Fine. So now we need to talk about algebraic expression. So terms are obtained or formed by what? Combination of multiplication and division. Now algebraic expressions are formed by combination of addition and subtraction. So an algebraic expression is formed by grouping the terms either by addition or subtraction. Terms are formed by multiplication and division. Algebraic expression is formed by addition or subtraction of terms. Fine. So let us observe some examples. Already in the previous case, we have seen terms. So the terms are 3x by 5, p and 3 by 5. Okay. So let me group those terms only. 3x by 5 is one term. P is another term. Even, okay, fine, 10. So I want to group these terms by what, children? Either addition or subtraction. So I'll go with subtraction and addition. So 3x by 5 minus p plus 10 is a algebraic expression. One algebraic expression. So how an algebraic expression is formed? Hope you understood, right? So algebraic expression is formed by grouping the terms either by addition or subtraction. Fine. So let us take one more algebraic expression. Let us observe one more expression. 3x square is one term, 5x is one term, and 10 is another term. So I'll add and then I'll subtract. So 3x square plus 5x minus 10 is also one algebraic expression. You can ask me what is the difference between first one and second one. So in the first one, we have two variables. I'll just shade it. One is x and one is p. But in the second one, we have only one variable, that is x. That's it. So you can clearly understand an algebraic expression can have any number of variables. Maybe 2 variables or 3 variables. Okay. Suppose if it has only one variable, then we say that algebraic expression with one variable. If it has two variables, with two variables, like that. Okay. So hope you are following. Now let's talk about polynomial, children. polynomial. So please observe carefully the definition of polynomial. An algebraic expression, an algebraic expression which involves variable, which involves variable. Okay, already we have discussed what is a variable. With non-negative, I'll write and I'll explain, don't worry. With non-negative integral power. With non-negative integral power is called as a polynomial. With non-negative integral powers is called as a polynomial. So already we have discussed what is an algebraic expression, or we have seen how an algebraic expression is formed in the previous case. So let me take the same example. Please observe carefully, but I want to change the polynomial, variable. So 3x, maybe 3x square minus x plus 10. Okay. Then the second one, maybe say this is 1 and say this is second one, 3x square plus 5x minus 10. Fine. And let me write two more to understand the polynomial definition very clearly. Then 3 root x plus 5x square minus 10. Fourth one, 3 by x minus 5x square plus 10. Okay, fine. No doubt all these four examples are algebraic expressions. Children, please observe carefully. There is no doubt at all. All these four expressions are called as algebraic expressions, are also called as multinomial. I'll write here. I'll write on the left hand side. Please observe carefully. All these four examples are algebraic expressions or multinomial. But now coming to our definition, our requirement is polynomial. We want to define a polynomial. So let us again check the definition. An algebraic expression which involves variable. In all the examples we have variable. With the non-negative integral power. Sir, what is this non-negative integral power? So first we need to understand integral. Integrals are nothing but integers. So when we talk about integers, yes, combination of positive numbers and negative numbers along with 0 are called as integers. Right, children? So they are integers. Both positive and negative including 0 are called as integers. Fine. But in that we need non-negative integral powers only. Means, see, non-negative, clearly positive, even it can have 0 also. Together 0 are called as non-negative integers. Fine. So the power of the variable, you take any variable or any expression in that the power of the variable must be positive or 0. Okay, fine. So here 2 positive, here 1 positive. Okay, here 1, fine. But if you just observe carefully, we have here 3 root x. So this can be written as 3 into x power 1 by 2. Is 1 by 2 is an integer? No. 1 by 2 is not an integer. Maybe it is positive, but it is not an integer. Hence, this entire expression is not a polynomial. Why? Because the power of the variable is not an integer. Maybe positive plus 1 by 2, but it is not an integer. Fine. So it is not a polynomial. The first two are no doubt polynomial. And coming to the fourth one, even here also we have 3 by x. If you have remembered from the powers and exponents 7th grade, we have learned one formula, a power minus m equal to 1 by a power m. A power minus m equal to 1 by a power m. So this 3 by x can be written as 3 into x power minus 1 according to this formula. So here also again, the power is clearly observed as negative. So 3 by x, though when it is in the denominator, x power is 1, so it is positive. But when you write it in a proper order, proper pattern, then the power of x is negative and it is not a polynomial. So clearly remember, blindly I can say, if the variable is in the root or if the variable is in the denominator, then those type of expressions are not polynomial. Hope you have already learned, if you are from CBSE background, you have already learned in second chapter polynomials from CBSE, right? Fine. Okay. So hope you understood what is a polynomial. Now, let us observe the standard pattern of a polynomial or the standard form of a polynomial. So which is written as a naught plus a1 x power 1 plus a2 x square plus a3 x power 3 plus and so on plus an x power n. All these are terms like a naught is one term, a1 x power 1 is another term, a2 x square is another term, a3 x power 3 is another term. Like that, each individual is called as one term. Okay, fine. So see children, here a naught, a1, a2, a3 are called as coefficients. Here a naught, a1, a2, a3 and so on, an are called as coefficients. Are called as coefficients. Fine. So here we need to talk about two cases all the time. For suppose, say case 1. If a naught, I mean to say coefficients only, a naught, a1, a2 and so on, an belongs to real numbers. Children, please observe carefully two cases clearly. If the coefficient a naught, a1, a2 and so on, an or belongs to real numbers. So again you can ask me, sir, what is the real number? Real number is nothing but combination of natural numbers, whole numbers, rational numbers, of course integers, then rational numbers, irrational numbers. Natural numbers, whole numbers, integers, maybe you can find fractions, decimals also in that, and after that rational numbers and irrational numbers. All this number system together is called as real numbers. So if these coefficients belongs to real numbers, then we say that that polynomial is called as real polynomial. And where that polynomial, that variable x will take all the real numbers. Children, if all these coefficients belongs to real numbers, then the polynomial is called as real polynomial, and that x, the value of x, I can say, will take only real numbers. For suppose, if all the coefficients a naught, a1, a2 and so on, an belongs to complex numbers. You all know complex numbers is nothing but again, see children, once again I'll just have a glance here. Natural numbers, and after that whole numbers, and after that integers, and after that we have rational numbers, then we have irrational numbers. All this is separate number system. All this together is called as real numbers or number system, main number system, real numbers. But apart from this, there is one more number system called as complex numbers system, which is denoted by C. So which is again combination of real numbers and imaginary numbers. Which is again imaginary NARY. Okay, and I'll write it neatly once again, just a second. So which is combination of Yeah, real numbers and imaginary numbers. Suppose, if you just observe carefully, 2 is one real number plus one imaginary. You take I or you take 3i. So 2 plus 3i, 2 plus 3i is called as one complex number, where I is called as imaginary. How that I is derived or will be coming to know in our next classes. Don't worry. Fine. So now we are talking about complex numbers. Okay. So if A0, A1, A2, and so on, An, they are nothing but coefficients, belongs to complex numbers, then the polynomial is called as complex polynomial. Complex polynomial. And where the value of x is based on complex numbers only, or the value of x will take from complex numbers only. So I have already shown you how the complex number represented as. Okay, fine. So we understood now finally what is a polynomial. Okay, of course, before that we have discussed blah blah blah. So, but we understood what is a polynomial, and after that we understood what is a real polynomial. Then we understood what is a complex polynomial. Fine. Now let's come into our chapter. But before that, we need to talk about even degree also before we enter into the chapter name. Yeah. So degree. How to find degree of a polynomial? So degree of polynomial is nothing but the highest power of the variable in that polynomial is called as degree. The highest power of the variable. The highest power of the variable is called as its degree. In that polynomial, okay, is called as its degree. Fine. So for example, if you take 10x power 9 minus 8x cubed plus 4x square plus 5. So here the highest power of the variable x is 9. So no doubt its degree is 9. So like that a polynomial can have nth degree, any power as its degree. Okay, fine. So now let us talk about some cases. So if degree is 1, then it is called linear polynomial. If degree is 2, then it is called quadratic polynomial. If degree is 3, then it is called cubic polynomial. If degree is 4, then it is called biquadratic polynomial. So like that 5 fifth degree, 6 sixth degree, n nth degree. Fine. Okay. So we have discussed what is a polynomial. Then we have discussed real polynomial, complex polynomial. Then what is the degree? Now let's enter into the topic. Our topic, that is quadratic equation. Fine. So please observe carefully. Okay, fine. So if a polynomial, f of x with degree 2, is equal to 0, say f of x is equal to 0, then it is said to be a quadratic equation. Then it is said to be a quadratic equation. Fine. So we have discussed what is a polynomial, and even we have discussed what is a quadratic polynomial. If that quadratic polynomial equals to 0, like becomes 0, then we say that it is a quadratic equation. Once again, if a quadratic polynomial is equals to 0, then it is called a quadratic equation. Fine. And the standard form of a quadratic equation always written as ax square plus bx plus c equal to 0, where a comma b comma c belongs to complex numbers, and of course a is not equal to 0 compulsory. This is very, very compulsory. Why? Because if a equal to 0, then here x square term will become 0. Why? Because a into or 0 into x square 0, and it becomes again a linear polynomial. Hence, always a is not equal to 0. So this is the standard form of a quadratic equation. Fine. So here also some cases are there in our material it is given. So I just discuss fastly. So first case, if b equal to 0, if in this quadratic equation, if b equal to 0, then it is called pure quadratic equation. If b value 0, for example, see 2x square plus 3 equal to 0. 2x square plus 3 equal to 0. So b means what? X percent. Yeah, who is this?
Can you explain again quadratic?
Yeah, so already we have discussed what is a quadratic polynomial. Polynomial first we have discussed, and after that we have discussed what is a quadratic polynomial. If the degree of the polynomial is 2, then it is called a quadratic polynomial. For example, 3x square minus 5x plus 10. This is a quadratic polynomial. Sir, what is the degree? Already we have discussed degree. Degree is nothing but the highest power of the variable in that polynomial. The highest power of the variable in that polynomial. See here, 10. So for 10, the degree is actually 0. Why? Because we can write it as x power 0. And here x power 1. And here x power 2. So among all these, the highest power is 2. Hence, its degree. I'll just write d is equal to 2. So these type of polynomials are called as quadratic polynomial. The polynomial in which the degree, for which the degree is 2, is called as quadratic polynomial. If that quadratic polynomial equals to 0, if we equate that quadratic polynomial, suppose, one second, I'll erase it, no problem, I'll explain this point again. So I have already discussed in the earlier case, 3x square minus 5x plus 10 is a quadratic polynomial. If we equate with 0, then it becomes a quadratic equation. Is that okay, ma? Soumya?
Yes, sir.
Did you understand? Fine. So please be here only. Be attentive in the class, please. Okay, fine. Now, so the standard form of a quadratic equation is ax square plus bx plus c, where a is not equal to 0 and abc belongs to complex numbers. Fine. Of course, you can take real also. If it is real, then it is called real quadratic equation. If it is complex, then it is called as complex quadratic equation. Already that point we have covered. Fine. So let us observe some cases. If suppose, if b value 0, sir, what is b? If you just observe carefully, b is nothing but x coefficient. Then the quadratic equation is called as pure quadratic equation. If b value means x coefficient is 0, then it is called pure quadratic equation. For example, please observe carefully, 2x square minus 5 equal to 0. In this, there is no x term. In this, there is no x term. Hence, this type of quadratic equations are called as pure quadratic equation. I'll repeat again. Pure quadratic equation means there should not be x term. There should not be any x term. Next, if a equal to 1, I'll explain. Then it is called monic quadratic equation. Sir, what is a? A means x square coefficient. We have already clearly shaded with yellow color. So everything you can observe here only, in this only. A means x square coefficient, b means x coefficient, c means constant. A is x square coefficient, b is x coefficient, c means constant. Fine. So if a is 1, then it is called as monic quadratic equation. Suppose I write x square minus 10x plus 8 equal to 0. See here, a is 1, means x square coefficient is 1. So hence, these type of quadratic equations are called as monic quadratic equation. Fine. So next one, third one, we have complete quadratic equation. I'll just write QE. And fourth one, incomplete quadratic equation. Incomplete quadratic equation. Okay. So we have discussed what is pure quadratic equation, what is monic quadratic equation. Now complete quadratic equation. The name, the word itself has meaning. Complete means it must contain all the terms. Means it must contain x square term, x term and constant. For example, see children, if I write x square minus 8 equals 0, this is not a complete quadratic equation. Why? Because in this x term is not there. Okay, so if I write x square minus 3x minus 8 equal to 0, yes, no doubt, it is a complete quadratic equation. Why? Because it has got all the terms. Now coming to incomplete quadratic equation. So incomplete means either b value 0, I'll write here, either b value 0 or c value 0. Means no x term or no constant. No x term or no constant. Means for example, x square minus 4 equal to 0. See here, no x term. So these type of quadratic equations are called as what? Incomplete quadratic equation. Or suppose x square plus 4x equal to 0. In this, there is no constant. So these type of quadratic equations are also called as incomplete quadratic equation. Of course, these are just like types only. Okay, that is not that much important. Fine. Now let's enter into the real scenario of the chapter, that is roots. And after that, we have to discuss nature of the roots, and after that, we have to discuss so many things. Okay, fine. Here, today, we have just discussed what is a polynomial, how the polynomial is derived, and how the quadratic equation is derived from the polynomial, and all we have discussed, and some basic types of quadratic equations. Fine. Now let's move to the actual topic of this chapter from aim 1 in your textbook or in your material, that is roots of the quadratic equation. Roots of the quadratic equation. Fine. So what is this roots? What is the meaning of root of a quadratic equation? Fine. So we have already discussed about the standard form of a quadratic equation. Ax square plus bx plus c equal to 0, where compulsory a is not equal to 0. Why? Because if it is 0, then there will be no x term and it becomes a linear equation, and that is why it is compulsory to be a is not equal to 0 and a comma b comma c belongs to complex. Fine. See children, this is the equation. This is the equation. So we can substitute any value in the place of x, or rather I can say we can substitute any value for x for satisfying. As it has equal to 0, I'll repeat again, as it has got equal to 0, we can substitute any value. Suppose if you get 0, then we say that it is satisfying. If you didn't get the 0, if you not get the 0, then we say that it is not satisfying the equation. So for what values of x? For what values of x it satisfies? So you can ask me once again, what do you mean by satisfying? Satisfying means if you substitute particular x value and if you get equal to 0, on the right hand side we have equal to 0. So if you get equal to 0, then it is said to be satisfying, or that x value satisfying this equation, or simply yes, it is satisfying the equation. Hope you understood satisfying. So now let us talk about once again rule. The value of x or the values of x. The values of x for which the equation satisfies is called as a root, or also called as solution. I'll write here the values of a variable. Here variable is x only, no? A variable x for which the quadratic equation, I'll just write shortcut children, the quadratic equation satisfies or satisfying. So satisfying means if you substitute that x value, you have to get 0, as we have on the right hand side, RHS side 0. That is called satisfying. Fine. Satisfying are called as roots are also called as solutions. We can even call it as solutions. We can even call it as solutions. Roots of a quadratic equation or solutions of a quadratic equation, both are same. You can use either roots or solutions. No doubt at all. Fine. So you can ask me now at this point, sir, like that, like for how many values of x it satisfies? For how many values? I told values of x. So you can substitute any x value, no problem. Any value for x or in the place of x. But it satisfies only for two values of x, not for all, not for many. It satisfies, though you substitute any x value, it satisfies for only two values of x. Okay, so why and all I'll explain in the next class, don't worry. So it has got only two roots. I'll repeat again, as it satisfies this quadratic equation satisfies only for two values, so it has got only two roots. And those two roots are denoted by alpha and beta. So once again, any quadratic equation you take, any quadratic equation, it satisfies only for two values of x. Only two values of x. Hence, every quadratic equation we can say clearly has two roots only or has two solutions. And those solutions are denoted by alpha and beta. Fine. And how to find those roots and all we will see now. Fine. So please observe carefully. So we know that the standard form of a quadratic equation is ax square plus bx plus c equal to 0. To find the root is nothing but x value. To find the root or solution, we have to find x value. That is only our root. Okay. So to find the x value, we have to convert this into a proper square. Maybe a plus b whole square or a minus b whole square. Fine. So first, divide the entire equation by a. Fine. So then ax square by a plus bx by a plus c by a equal to 0. We are just dividing the entire equation by a. So where a and a get cancelled, we get x square plus b by a times x plus c by a equal to 0. I have already told you we need to convert this into, I'll write here on the right hand side, either a plus b whole square or a minus b whole square. Then only we'll get x value. Fine. So you can ask me, which one I have to use, a plus b or a minus b? So clearly, here all the terms are positive, like we have plus plus. So better to use the first formula, that is a plus b whole square. So we all know how to expand a plus b whole square. A square plus 2ab plus b square. Fine. A square, so the first term is x square. We have the first term, that is x square. But coming to the second term, 2ab. So you have to make the second term b by a. See children, you have to make the second term b by a as 2ab. So from this, you have to identify what is a value, what is b value. So please observe carefully. Please observe carefully. So 2 into, anyway a is x, like a square x square. So after like comparing a value x into b equal to b by a x. X get cancelled. Don't think that b get cancelled. No, this b is different, that b is different. So b equal to, like this b belongs to our formula. Okay children, fine. So b by, I want to transpose 2 to right side, then you will get 2a. So b by 2a is our b. So I can rewrite this as 2 into, see 2ab, we want 2ab. A into b, our b is 2, b by 2a. So again, see 2 get cancelled. If you want, I'll just do it lightly. 2 get cancelled. Again, I'll get the same term. b by a x only, same term, right? Okay, so a square plus 2ab plus b square. There is no b square in the previous equation, so you have to provide your own b square. Our b is b by 2a, so b by 2a whole square. This is extra term, right? So we have added extra. So you have to subtract the same thing again to make it balance. Plus c by a equal to 0. So from here to here, clearly it is in the form of a square plus 2ab plus b square. So which is nothing but a plus b whole square. Okay, children? Equal to, now what we do is, let us transpose. Yeah, Shrestha, tell me, Amma.
So will you please explain 2ab equal to b by ax formula again?
Okay, fine. So no issues, no problem. No problem, Amma. Okay, fine. So here we get x square plus b by a x plus c by a equal to 0. Okay, now what we want to do is, we want to convert this entire equation into a square plus 2ab plus b square, which is equal to, of course, we know that a plus b whole square. Now, please observe carefully term to term. Please observe carefully term to term. Fine. So here x square is there, here a square is there. So if I compare, I will do at left hand side. If I compare those two terms, like x square and a square, square get cancelled. Indirectly, I'll get a value x. Okay. I got a value. I need to get b value now. Now let us compare the next term, next two terms. Okay, fine. So here, one second. Yeah. So here in the formula we have 2ab. On the other hand, we have b by a x. Shrestha, are you following, Amma? This is what you are asking about. Okay. Now 2 into, already we got a value. How much? X. So in the place of a, I am writing x here. Into b equal to b by a x. X get cancelled. Now I want to get b value. So I have to transpose this 2 to right side. So what I'll get? B by 2a. Is that okay, Ms. Shrestha?
Yes, sir. Thank you, sir.
That is how, yeah, thank you. That is how b value is b by 2a. So, yeah. So I think, okay, fine. So no problem. Hope you all understood what is a value, what is b value. So till here, we will like conclude today, and tomorrow's class we will continue with like completing the square method and finding x value, and after that we will see how to find sum of the roots, and we will see how to find product of the roots. So thank you, children. Thank you all. If you have any doubts also, you can ask like other people how they are raising their queries. You can ask me in the middle of the class. Definitely I will re-explain once again. Okay, don't worry. Thank you all. Thank you, children. Thank you. Yeah, sir. My session is done.
Thank you,
Yeah.
Jagdish garu.
Yeah. Thank you, sir. Thank you. Thank you. Thank you, sir. Thank you. So,
Okay,
shall I leave, sir? Shall I leave?
Okay, sir. Next time,
Yeah,
another class. Which class, sir?
I think chemistry, sir.
Sir,
Chemistry.
once can you show the answer, sir? The a x square, a plus b whole square one from starting. Yeah, sir. Thank you.
Sudhir, sir.
Thank you, sir.
Sudhir, sir. Thank you, Sudhir, sir.
Yes, sir, I'm here.
Okay, sir. I think you only know, sir. Next.
Sir, I will continue.
Okay, okay. Thank you, sir. Thank you. Thank you. Okay. Yeah.
Thank you, Jagdish garu. Sudhir garu.
Yes, sir.
Please continue, sir.
Okay, sir. Okay, ma'am. Very good evening, all of you. I hope my voice is clear for everyone. Can you hear me properly?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So today onwards in the chemistry sessions, we are going to focus on electrochemistry topic. So I feel already you have completed in your regular teaching classes. Am I right? Electrochemistry topic is scheduled at beginning of the academic session in C2 syllabus. Okay, so however, you have learned that, but the way how we have to understand the concepts and all by targeting our final aims in future. Okay, so all of us, why we are focusing on the foundation and all, because we are going to write different competitive examinations in future. Once after finishing the +1 and +2 are intermediate. So we are going to write and we are going to achieve the best ranks in the IIT or else in the NEET. So like that. So with that kind of intention only, we are focusing on these objective practice and all. So whenever we are preparing any topic in the chemistry or else in any subject, so how to practice the concept and how to focus on the objective content. So these two important things I would like to focus in my all sessions hereafter, along with the topic discussion. Okay. So here electrochemistry, if you understand, whenever you're going to learn the topic, we need to understand why we have to learn that particular topic. Why? Because chemistry, especially if you take, so it is always associated with our day-to-day life. Am I right or not? Will you accept with me what I said? So chemistry is always associated with our day-to-day life, right or not?
Yes, sir.
Yes, no? So wherever you go, so chemistry follows us in our day-to-day life, right? So because there are all chemical reactions we have, and all these chemical reactions we are utilizing in our day-to-day life to synthesize different chemicals and all, or else in our body also, the metabolic activity. Okay, so the metabolic activity, everything is led by different kinds of chemical reactions and all. So when we are learning a particular topic, why we have to learn the topic? First, you need to understand what is the importance of the topic or what is the scope of the topic in our day-to-day life also, we need to understand. So in this topic name itself, if you see, there are two parts I can say. One is electro and the second part is chemistry. So electro means it is standing for electricity. Already we know that. In physics also you are learning very much about electricity and all, current electricity. Okay, so the usage of electricity, how it is internally related to the chemistry. That is the main motto of this chapter. That's what mainly we are focusing and we are going to study in this electrochemistry topic. Okay, so now here if I say what is the main scope of this chapter, why we have to study this electrochemistry and where it is useful for us in our day-to-day life also, we need to understand, I said. So when it comes to this electrochemistry, the scope of chapter or importance of the chapter, so it is mainly useful for us in order to prepare or synthesize different chemical substances by the process of electrolysis. Okay, so by the process of electrolysis, we can synthesize or we can manufacture different kind of chemical substances which are very much important for our day-to-day life. That is the most important point which we need to remember before entering into this topic. And not only the preparation of chemicals, we can also observe or we can also find the applications of this chapter even in the extraction of metals. Okay, so we know in the earth crust, if you see, as per the periodic table, how many elements we have? Can you tell me? As per the periodic table, how many elements we have in the nature?
118.
Yes, 118 elements we have. Very good. So these 118 elements up to 92 we are taking as naturally occurring elements, and remaining all we are taking as man-made elements. Artificially we are synthesizing. So naturally occurring elements where we can see in the existence wise is they are present in the different compounds formed in the earth crust. So from these compound forms, if you want to use those metals in our day-to-day life, we have to extract them in the pure form. Okay, so the way how we are using sodium chloride in the compound state directly in the cooking process. Likewise, when it comes to the metals alone, in the pure form, we need them so that we have to extract the metals in the pure form. And after extracting them in the pure form, we can put them in different uses. Okay, so in the case of extraction of metals also, this electrochemistry chapter plays very important role. Okay, and not only these, and we can also say where it is very much useful or important is in the battery or in the fuel cells. Okay, in the preparation of batteries or fuel cells also, it is playing a key role on the working principles of batteries or else the fuel cells. Okay, these all are just non-living applications, I can say, right or not? So preparation of chemicals or extraction of metals or the preparation or manufacturing of batteries or fuel cells, all these are generally the non-living applications. Okay, abiotic applications, I can say. Okay, but even this electrochemistry plays a very important role in the biotic manner also, or in the biotic aspects also. Biotic means in the living things. Okay, so here how this electrochemistry is very much important in our body is it is playing key role in the main signaling systems from the brain to the neurons, brain to the other body parts by the neurons. Okay, so the brain usually it is sending some signals. Okay, so based on those signals only we are responding from time to time. Our metabolic activities or everything, our functioning of the body is mainly decided based on the signals which are sent from the brain. So in the signaling system of the brain also, this electrochemistry is playing very important role. Okay, so there are many applications we can list out, but the few important applications are the scope of chapter I need to present you. That's why I have taken these 4 important points. Okay, so one is in the preparation of different chemical substances, which are very much important for our day-to-day life. And the second one is in the extraction of metals. Third one is in the preparation of batteries or fuel cells. And in the fourth application or scope of the chapter, if I take, it is playing very important role in the signaling system of the body. Okay, so these are the main applications we need to remember when you are going to enter into this topic. Okay, so now I'm going to describe what is the exact meaning of this chapter. Okay, so as I said already before, electrochemistry. There are 2 important words we have seen already, I said. And electrochemistry, whenever I say electricity, we are going to study in this case how it is useful in the chemistry we are going to study. And chemistry is mainly related to the chemical equations or chemical reactions, whatever we study in our day-to-day life. Okay, so by relating these two, electricity and chemical reactions, the total study of electrochemistry is developed. Okay, so based on this criteria, if you ask me to define the electrochemistry, there are different possibilities of the definitions we have in the electrochemistry definition. Okay, so the first definition I can say, so you can see on the screen, I hope it is clearly visible to everyone. Okay, now, can you see the screen properly?
Yes, sir.
I zoomed it. Okay.
Yes, sir.
So, yeah, very good. So now here, if I take electrochemistry definition in 3 different ways, we need to define, because based on each and every statement, some part of the lesson we are going to understand very clearly in the upcoming topics. Okay. So the first definition which I would like to provide you for the electrochemistry is, so it is a branch of physical chemistry that deals with the production of electricity from energy produced from a spontaneous chemical reaction. This is one part of the statement. Very carefully you need to understand. Okay, so if I exclude this beginning part, here what mainly I need to focus and understand here is production of electricity from energy produced from a spontaneous chemical reactions. Okay, so I request you, please make a note of this word, spontaneous chemical reaction. So here you need to very clearly understand what does it indicates or what is meant by a spontaneous chemical reaction. Later I'll explain in the upcoming discussions. Okay, so we are going to produce electricity from the energy produced from the spontaneous chemical reactions. That is one way of study we are going to involve in this chapter. Or else, here, the second part of the statement, if you see, the use of electricity to bring about a non-spontaneous chemical reactions. Okay, the use of electricity in order to bring about a non-spontaneous chemical reactions. So here, if you understand these 2 parts of the statement, these 2 are vice versa, I can say. In one way, we are going to produce the electricity from the chemical reactions, which are spontaneous in nature. And in another way, we are going to make a chemical reaction to happen, which is a non-spontaneous, by using the electrical energy or by using the electricity. So these two different kinds of studies we are going to do in the electrochemistry. Okay, that is a branch of chemistry which deals with these two important areas of the study. That is statement 1 you need to understand. I hope it is clear. Any doubt here in this statement? Every term I will describe now after finishing these 3 statements. Okay. So now next definition or next statement if I take here, the branch of chemistry which deals with the study of all chemical and physical process in which electricity is produced or consumed. The same kind of statement, but in a simplified way we have taken. Either it may be a physical process or it may be a chemical process, the consumption of electricity or the production of electricity. These two we are going to study in this chapter mainly. Or else the third statement also, if you see, it is the study of interconversion of other forms of energy into electrical energy or vice versa. That means what? We can convert the electrical energy into other forms of energy, or else the other forms of energy can be converted into electrical energy. Okay. So this kind of study also mainly we are going to focus in this electrochemistry chapter. Okay, na? So how many terms here mainly you need to understand? I'm recapping again, just make a note of it. So here, the first and most important thing you need to understand is spontaneous chemical reaction and at the same time, non-spontaneous chemical reaction. So what is meant by these two terms, you have to remember very carefully. And another thing is how to convert. Here, interconversion we are taking. So how to convert one form of energy into another form of energy also we need to understand very carefully. Okay. So is it possible to convert one form of energy into another form of energy? Can anyone of you tell me? In physics, you have law of conservation of energy, right? Can you tell me what is law of conservation of energy? Yes, please. Law of conservation of energy. It is mainly telling about the internal conversion of energy, right? Energy can be neither created nor destroyed, but it can be transformed from one form to the another form of energy. Am I right?
Yes.
Yes, it is
sir.
very it is very similar to our law of conservation of mass when it comes to chemistry. Right or not? In law of conservation of mass also, what is the statement we are using? Matter can neither be created nor destroyed. Matter can neither be created nor destroyed, but matter can be transformed from one form into another form. That is what we are telling here, law of conservation of mass in chemistry. In the similar way, in physics, we are studying in detail about law of conservation of energy. That is mainly focusing on the interconversion of different forms of energies. So through this electrochemistry chapter, we are going to focus how we can convert the different forms of energy into other forms. Okay, na? So this is the main thing we need to understand before entering into this topic. Okay. So now, when I'm telling you, I asked you to remember there are two important terms we have to understand clearly. One is spontaneous chemical reaction and the second one is non-spontaneous chemical reaction. Okay. So here, in this chapter, even though different forms of energies we have, mainly what kind of energy conversions we are focusing is electrical energy and chemical energy internal conversions we are going to focus. Okay, please make a note of this point. In electrochemistry topic, we are going to focus mainly on conversion of electrical energy into chemical energy as well as the conversion of chemical energy into electrical energy we are going to mainly focus. Okay, so if you see on the arrowhead, I have used these two terms only above which I told you to remember. So here, the conversion of electrical energy into chemical energy is always done by a non-spontaneous chemical reaction. Okay, the conversion of electrical energy into chemical energy is always done by non-spontaneous chemical reactions. And when it comes to the conversion of chemical energy into electrical energy, it is always done by spontaneous chemical reactions. Okay. So in order to have this type of internal conversion of energies, we need to understand without a doubt we have to understand here non-spontaneous means what and spontaneous reactions means what. Okay. So now here I'm using in general spontaneous reactions and non-spontaneous reactions. But exactly speaking, here we need to understand spontaneous redox reactions and non-spontaneous redox reactions we have to use. In these two internal conversions, mainly we have to consider non-spontaneous redox reactions and spontaneous redox reactions we have to consider. Okay. So for that sake, first we have to understand what is a redox reaction. Can you tell me, any one of you, what is meant by a redox reaction? You can unmute and you can speak, Ma. It is a kind of discussion. Don't be quiet and don't be silent. Okay. Yes.
The reaction which takes place with both reduction and oxidation, sir.
Okay, very good. Okay, only one student is responding. What about remaining?
Gain of electrons or loss of electrons is known as reduction.
Okay, very good, ma. Fine. So here my question is, what is meant by a redox reaction? Okay, first you confirm that. So what she said is correct or incorrect? What is redox reaction?
Correct, sir, in which oxidation and reduction takes place.
Yes, very good. Okay, so generally we can see different chemical reactions. Okay, so in all the chemical reactions, we may not observe oxidation process and the reduction process simultaneously. But in which chemical reactions, okay, in which chemical reactions both the reduction and oxidation takes place at a time or simultaneously, those type of reactions are generally called as redox reactions. Okay, so here you need to understand one important thing. I'm telling you in the statement itself, both oxidation and reduction takes place simultaneously. That means, can I say like this? In any redox reaction, if one reactant is undergoing oxidation means definitely another reactant must undergo reduction. Okay, can I say like that?
Yes, sir.
Yes, no. So definitely, if one substance is involved in the oxidation process in a particular chemical reaction means other substance must be involved in the reduction process. Then only the oxidation and reduction process will occur simultaneously in the chemical reaction. Okay. So whatever it may be, the reactions in which both reduction as well as oxidation takes place simultaneously are called as redox reactions. Please remember this basic term. And next, we need to understand what exactly meant by oxidation and reduction process. So the second student, you have answered no. So now here if I say what is meant by oxidation and what is meant by reduction, here these are the possible statements I have listed out. So in general, at basic level, we define oxidation and reduction with respect to only the addition of hydrogen or removal of oxygen, like that. So with respect to hydrogen and oxygen elements only, we used to define at the basic level of the topic. Okay, but when it comes to this chapter especially, or else in the general redox reactions also, whatever the possible statements or definitions are there, every definition is very important, and especially in electrochemistry, all these definitions are very important. Okay, so now when it comes to oxidation process, please make a note of it. Addition of oxygen, it is a basic definition, already we know. Addition of oxygen is called as oxidation, or else the removal of hydrogen is also called as oxidation process. Okay, so with respect to hydrogen and oxygen, we can define the oxidation process like this. We know very well about these two: addition of oxygen or removal of hydrogen. Okay, now I'm going to focus on these three other definitions which are given under oxidation process. One statement I am telling here is loss of electrons is called as oxidation. Loss of electrons is called as oxidation, and increase in the oxidation number is also called as oxidation, or else the addition of electronegative element is also called as oxidation. Okay, please, if it is possible, make a note of all the possible statements. Okay, now loss of electron is called as oxidation. Increase in the oxidation number is also called as oxidation, or else the addition of an electronegative element to other substance is also called as an oxidation. Okay, so now I'm asking you, what is the reason behind why mainly all these kinds of process we are treating as oxidation. Okay, definition means anyhow you will say, no doubt about it. That's why I'm asking you the reason behind why we need to consider addition of oxygen as oxidation process. Can any one of you tell me, please? Why we have to consider addition of oxygen as oxidation process? Can you tell me? If I ask you a statement, easily you will say addition of oxygen is called as oxidation process. But why we have to consider like that? Why addition of oxygen is called as oxidation process? Or else removal of hydrogen is called as oxidation process? Please, any one of you? Reasons. Okay, fine. So I'll explain. I will give you clarity here. So here, whenever we are defining these using these basic definitions, if the hydrogen and oxygen elements are involved in the redox process, then only it is possible. But in general, for any kind of chemical reactions, we can apply these other three parameters in order to decide whether it is oxidation or reduction process. Okay, whether it is oxidation or reduction process, easily we can understand. So let me conclude the definitions of reduction. Then I will go to explaining why we have to consider like this. These set of statements as oxidation process and other set of statements as a reduction process. Why we have to consider like that, I will explain you parallelly two things. Okay. So when it comes to reduction process, definition wise, it is quite opposite of oxidation. Once you compare the statements which I have provided, in the oxidation I have given addition of oxygen is called as oxidation. But here when it comes to reduction, as it is an opposite process, I can say removal of oxygen is called as reduction. And here removal of hydrogen is oxidation. But in this case of reduction, addition of hydrogen is called as reduction. Okay. So like that, exactly the contrast or opposite statements we can give here. Loss of electron is called oxidation, but gain of electron is called as reduction. Increase in the oxidation number is called as oxidation. Decrease in the oxidation number is called as reduction. Here means addition of electronegative element, that is called as oxidation. But here in this case, electropositive element addition. Addition of an electropositive element is called as reduction process. We need to understand. Okay, so I hope definitions wise you don't have any doubt or any concern. Can I move on to the next one? Next topic.
Sir,
Yes, ma'am.
Yes, sir.
Okay.
can you give some example for electronegative and electropositive
Yeah.
elements?
I am telling you. I will take examples and you also has to practice now itself. Okay, na? So generally electronegative elements means you can take like fluorine, chlorine, oxygen, nitrogen, these type of elements. Okay, na? Non-metals generally we can consider. Non-metals are generally considered as electronegative elements. Okay. Why we are calling them as electronegative elements means always they will gain electrons and will be converted into negative ions. Right or not? If I take oxygen, it is accepting 2 electrons and it is converted into O-2. Right or not? In the fundamentals also we have learned in the lower classes in all ions list. O-2 oxide ion is there. Right now? Or N-3 nitride ion. Nitrogen is gaining 3 electrons and it is converted into N-3. So whenever the element is having tendency to gain the electrons, okay, that property generally we are taking as electronegative character. Okay, why we are treating it as electronegative character? Because of gain of electrons, the neutral atom is converted into negatively charged ion. That's why here we are treating those elements as electronegative elements. For electronegative elements, non-metals you can consider as an examples, and especially or specifically if you want to talk about oxygen, nitrogen, fluorine, chlorine, bromine, all these type of elements we can treat as electronegative elements. Okay, ma?
Sir, then you said the oxidation means loss of electrons.
Yes. Yeah, that's what I will give you clarity. Reasons I am asking, that's why. Okay. Generally, definition or statement anybody can remember. But reason behind why we are defining in such a way, we need to understand. That's what I'm trying to give you the clarity. Okay. So electropositive means, metallic elements we can consider generally. Why? Because they will be having losing tendency. Okay, they will be having electron losing tendency, so that by losing electrons, the neutral atoms are converted into positive ions. That's why that character we are taking as electropositive character. Okay. So metals generally can be considered as electropositive in nature. Non-metals are generally considered as electronegative in nature. Okay, am I clear?
Yes, sir.
Yes. Now, your question, I'll answer. Okay. So why we have to consider electronegative nature? Why? Because electronegativity is gaining a process. But here, loss of electron is called as oxidation, we are telling. Right now, that is your doubt. So now, I'm taking hypothetical examples first. Then I will take some actual examples. Because hypothetically, when you get the clarity, you can apply that concept to any particular given situation in the exam. Okay. So in a general format, first you need to understand the concept. So now here I'm taking X, element X and element Y. Okay. These two I'm taking, element X and element Y I'm taking. Okay. So now in this process, if you understand, I have represented one electron is being transferred from element X to Y. Okay. Now element X to Y, one electron is being transmitted or transformed. That means I can say here, X is losing electrons and Y is gaining electrons. Okay, na? X is losing electrons and Y is gaining electrons. Now, as per this process and above statements, if I apply, X is electropositive in nature or electronegative in nature, ma? Tell me, please. Element X, I can say electropositive in nature or electronegative in nature.
Electropositive.
Yes, very
Positive.
good. Yes, very good. Electropositive in nature. And what about Y? Y is?
Electronegative.
Obviously, it is electronegative. Why? Because it is gaining electron from the X. Okay. So now here in this process, X is losing electron and it is electropositive. And Y is gaining electron, that is electronegative. Now tell me, if X is losing this electron, how this X can be converted? X is converted into X plus 1, I'll say. Yes, very good. X plus 1, I'll say. Okay, na? And Y is converted into
Y minus.
Minus.
Y minus 1. Very good. Okay, X is converted into X plus 1. Y is converted into Y minus 1. So once you go back and recollect the last three statements which I have given to you under oxidation and reduction. Okay, addition of hydrogen or removal of oxygen, all these, just you keep it aside for some time because we already know the fundamental definitions. But loss of electron is called as oxidation. Increase in the oxidation number is called as oxidation, or addition of electronegative element is called as oxidation, I said. Okay, na? Now, by taking reference of these three statements, I am applying to X. Why? Because X is losing electron and it is electropositive in nature. Okay. So now X is losing electron means, can I say X is involved in the oxidation process? Right or not?
Yes, sir.
X is losing electron means X is involved in the oxidation process. So loss of electron is called as oxidation. Will you accept? Okay. Loss of electron is called as oxidation. That is accepted.
So,
What is the next statement, ma? Increase in the oxidation.
gain of electrons is known as reduction.
No. Reduction I'll discuss separately. First, you conclude for oxidation. Okay. So loss of electron is called as oxidation. That statement we got clarity. Now, second statement, if I take, increase in the oxidation number is called as oxidation, I'm telling you. Right or not? Increase in the oxidation number is called as oxidation. Now, when the X is losing electron, how its oxidation number is changed? Initially, it is having 0. But now, after losing electron, what is the oxidation number of this X? That is plus 1. Right or not?
Yes, sir.
X initially in the elemental form, oxidation number is 0. After losing one electron, it is converted into X plus 1. That means its oxidation number is increased from 0 to plus 1, I say. Am I correct or incorrect?
Correct, sir.
Correct only, no? Now you tell me why this increase is observed because of loss of electron only, no?
Yes, sir.
Yes.
Yes.
Okay. That is the reason why always we are taking loss of electron is called as oxidation, or else increase in the oxidation number is also called as oxidation. So whenever the element is losing electrons, definitely its oxidation number will be increases. Okay, if the element or any species is losing electrons, its oxidation number will be increased. That's why we can relate these two statements in order to describe what is oxidation process. Okay, what is the last statement I said? Addition of an electronegative element is called as oxidation. Right or not? Addition of an electronegative element is called as oxidation. Now, as per the chemical bonding concept, once you understand, here X plus 1 and Y minus 1 are produced because of this transfer of electron. So now what happens between X plus 1 and Y minus 1? As they are oppositely charged ions, there will be some electrostatic force of attraction and they are forming an ionic compound. Right or not? X plus will be combining with the Y minus. Because of electrostatic force of attraction, we can say one ionic compound, that is XY compound, is formed in this process. Okay. So now in this entire process, after this loss of electron or the formation of positive ion, what finally I can conclude is I have added element Y to the X. Okay, I am telling like that. I am adding, or I have added element Y to the X. Correct or incorrect? You have to say, please. Element Y I have added to X. That is correct or incorrect?
Correct, sir.
Correct. What is the nature of element Y, ma? It is electropositive or electronegative?
Electronegative.
Electronegative. Okay. So as it is gaining electrons, Y is considered as electronegative element. That means I have added an electronegative element to the X. So because of this addition of electronegative element to the X, which process this X is undergoing? Oxidation process. Right or not? It is losing electron. Okay. In order to donate electron to this Y, it is losing itself so that it is involved in the oxidation process. So in such a way, whenever we are adding an electronegative element to the other substance, there will be loss of electron. Obviously, it is involved in the oxidation process. Okay, that's why we are defining oxidation with respect of addition of electronegative element also. Okay, now clear?
Yes.
Now you have to answer or you have to respond for this Y. So what all the points I have discussed with X with respect to X, now you try to apply. It is quite opposite to Y. Okay. So Y initially it is oxidation number. What is oxidation number initially? Any elemental form, it is 0 only.
Zero.
So Y is also 0. Very good. Now, because of this gain of electron, how this Y is converted, ma? Y is converted
Y minus
Y minus 1. Very good. So now 0 to minus 1. Increase or decrease in the oxidation number?
Decrease.
Decrease in the oxidation number. So is it that the fourth statement which I have provided? Decrease in the oxidation number is called as reduction.
Reduction.
Yes. Decrease in the oxidation number is called as reduction. So it is obeyed. So why the decrease is coming? I can say because of gain of electron. Right or not?
Yes, sir.
Okay. So because of gain of electron, that Y is converted into Y minus by decreasing its oxidation number. So gain of electron is always reduction process. I can confirm. Right or not? Okay. Now tell me last statement for the reduction. What is the last statement of reduction? That is addition of an electropositive element. Okay, na? So in the similar way, after formation of X plus and Y minus, what did I say? XY ionic compound is produced. So now if I talk with respect to Y, can I say X is added to Y after the reaction? Yes, obviously X is added to Y. Okay, what is the nature of X here, ma? It is electropositive.
Positive.
So because of that addition of electropositive element to the electronegative element or to the Y is undergoing reduction. Right or not?
Yes.
Okay, now final question I'm asking you. At the beginning itself, I said redox reactions means definitely one substance is undergoing reduction means other must undergo oxidation process. Okay. So now, if X is ready to lose the electron, Y is not there in the process. Can X undergo oxidation
No, sir.
No, sir.
or
No,
Y?
sir.
Okay, Y is there to accept the electron, but X is not there to donate the electron. Then no
Sir.
process.
Not possible.
So there is no process occurs. So that's why two substances are compulsory must be present in the redox process. One must undergo oxidation and other must undergo reduction process. We need to consider and we have to conclude finally. Okay. Am I clear?
Yes.
This is what exactly meant by oxidation and reduction process. So all these definitions and statements already we have learned. And once again, just I have given you some inputs, how to understand the statement clearly. Okay. So now, based on this particular process only, how to relate the statements and all, each and every statement of oxidation and reduction also we have considered. So finally, in this redox process, another two important terms which we have to understand is one is reducing agent and other is oxidizing agent. Okay, na? One is reducing agent and other is oxidizing. If you tell me what is meant by reducing agent and what is meant by oxidizing agent.
The agent which loses electrons is known as reducing agent.
Very good. Okay, and oxidizing agent means?
Which gains electrons.
Gains electrons. So here, directly don't use agent, ma. The species or the substance. Okay, the species or the substance which loses electrons. Okay, which loses electrons is called as reducing agent, and which gains electrons is called as oxidizing agent. Okay,
Yes,
so
sir.
this is a kind of definition we can apply or we can use for the reducing agent and oxidizing agent. Okay. So can any one of you tell me in any other form of definitions for reducing and oxidizing agents?
The oxidation is nothing but a reducing agent, sir.
Come again, please.
The oxidation is nothing but a reducing agent.
Okay. So little correction, not the oxidation, ma. The substance involved in the oxidation process. Okay. The substance involved in the oxidation process is generally acting as a reducing agent. And the substance involved in the reduction process is generally acting as an oxidizing agent. So it is quite oppositely we have to consider when it comes to the respective agents. Okay. Clear or any doubts? Okay. So here X is involved in the oxidation by losing electron. That's why it is considered as reducing agent. And Y is involved in the gain of electron. It is undergoing reduction. So it is treated as oxidizing agent. Okay. So like that, opposite substances we have to consider when it comes to the respective agents. Okay. Or else simply if you want to say also the electron losing species in the redox process, that is generally as reducing agent. And electron gaining species is generally considered as oxidizing agent. Okay, na? Clear?
Sir,
Yes, ma'am.
oxidation means losing electrons, but electronegativity means gain of electrons.
Yes. What is the? Come again, please.
Difference, sir?
No. Difference in the sense here, electropositive and electronegative natures. These two are the properties of elements, ma'am. Okay. Electropositivity and electronegativity are the properties of elements. That's what I said. Electropositive nature means electron losing tendency. Electronegative nature means electron gaining tendency. It is the nature of the species. Okay. Based on that nature of the species, we are defining the process now. In which kind of process it is involved. Okay. So because of loss of, because of electropositive character, that species is always losing electrons. So when there will be an increase in the oxidation number, so that we are telling it is oxidized. Okay, the species which is involved in the loss of electron is oxidized. Likewise, electronegativity is the nature of element. Because of that nature, in which kind of process it will be involved? In the gaining of electrons process. Gaining of electron is called as reduction only, no? That's why we can say that electronegative species is undergoing reduction process. That clarity we must maintain. And once after knowing which is involved in the oxidation and which is involved in the reduction, now when it comes to the agents, oppositely we have to consider acid. What is that opposite factor? If the substance is involved in the oxidation process, it must be considered as a reducing agent. Opposite. Itself it is involved in the oxidation, but it acts as a reducing agent in the redox reaction. And likewise, itself it is involved in the reduction process, but it acts as oxidizing agent in the redox process. Little more clarity I'll give you. Please make a note of it. So already I said in the redox process, both the substances must be there. If only one is existing, the process cannot be occurred. That's what I said. Okay. So now, because of why X is involved in the oxidation, I say, I'm correct or incorrect? Because of Y only, X is involved in the oxidation.
Yes.
Right
Yes,
or not?
sir.
If
Yes,
Y
sir.
is not there, X cannot be involved in the oxidation, right or not?
Sure.
Okay. So that means I can say here, because of Y only, X is involved in the oxidation process. Okay, na? Because of Y only, X is involved in the oxidation process. So it is supporting the oxidation of X here. That means, can I consider as oxidizing agent? Y is acting as oxidizing agent. Right or not?
Yes, sir.
Yes, no, simple. For example, just better understanding I am giving you. Okay. For example, if a person is working in the bank or else in the LIC. Okay. So generally we call them as LIC agents. Right or not? Okay. LIC agents, we call them. So policy or insurance matters related to LIC only. Okay, so which agent you are telling, that agent must support that particular thing. So if a person is working in LIC as a LIC agent, he will always support the LIC policies. Okay, or else if the person is an employee of HDFC Ergo, so he will support or she will support only Ergo policy. Okay, like that. So like which kind of agent they are working, always they'll support that. So here also we are telling it is acting as oxidizing agent. Okay, it is acting as oxidizing agent. That means it will be supporting for which type of process? Always it will support the oxidation process of others.
Oxidation.
Yes. Okay. That's why itself it is involved in the reduction process, but it is always supporting the oxidation of others. Okay, na? That's why we are treating here Y as oxidizing agent. And likewise, reducing agent means it will always support for reduction of others. Okay, it is supporting reduction of others. Imagine now, if X is not there in this process, can Y undergo reduction? No, no. Because electron must be there. Okay, who is donating that electron? X is donating that electron. So if the X is not donating that electron, Y cannot be involved in the reduction process. So X is supporting the reduction of Y here. That's why this X is treated as a reducing agent. Okay, na? Clear or any more doubts?
No, sir.
No doubt, sir.
Understood, ba? Okay.
Yes, sir.
Yes, fine. Yes, fine. So I hope you are very clear now. What is the scope of the chapter? What is the main internal conversions we are going to have? And what is the redox reaction? How can we define the oxidation and reduction? And how to understand which is involved in the oxidation or which is involved in the reduction process. Okay. So now detailedly we have studied about redox reactions and what are the different things we need to understand in that process. Now, very important thing which I am telling you now, redox reactions are mainly classified into two important types. Okay, one is spontaneous redox reaction And the second one is non-spontaneous redox reactions. Okay. So simply you can understand, ma. I don't want to take much time, just 5 minutes, you stay back. That is enough. Okay. So here, spontaneous redox reactions means themselves they will occur in the nature. Okay. The moment when we mix the chemicals in the reaction mixture, automatically the reaction will take place. Those type of reactions are generally called as spontaneous redox reactions. We know as per the language also, spontaneity means what? Okay, just very randomly we may express our words and all, or we may speak. Okay, if any debate competition is there, very spontaneously we speak. Okay, even though we don't have any preparation, when we have command on the topic. Like that, even the chemical reactions also, what happens in the nature themselves, whenever we are mixing the chemicals, without the help of any external energy and all, the reactions can be completed. That's why those type of redox reactions are called as spontaneous redox reactions. Once you see the statement, occurs themselves with no external force. Okay. So man-made help is not at all required for these type of reactions. Themselves, they will occur. That's why these are called as spontaneous redox reactions. Okay. Best example, which already we know, displacement reactions. Okay, displacement reactions means what? A more reactive element will replace the less reactive element from its salt solution. Okay, now, do you have any idea on the displacement process?
Yes, sir.
Yes, no? Yes, very good. So, based on the reactivity series of metals, even in the 8th standard also we have studied. Okay, so based on the reactivity series of metals, a more reactive metal will always displace less reactive metal from its salt solution. Those type of reactions are called as the displacement reactions. So displacement reactions are very good examples for spontaneous redox reactions. So for example, I'm taking copper sulfate solution in the test tube and I'm dipping zinc metal pieces in that copper sulfate solution. So when I compare the reactive nature of zinc and copper, zinc is more reactive than copper. So automatically what happens? Zinc will displace copper from its solution and it forms zinc sulfate and copper in the neutral metallic form. Reddish brown colored copper is precipitated or coated on the zinc metal piece. Okay. So the moment when I'm adding small pieces of zinc metal to the copper sulfate solution, itself the reaction can occur. Such type of reactions are generally called as spontaneous reactions. Okay, for better understanding, I can also give you one more example. Rusting of iron you take. In our day-to-day life, generally we used to observe iron particles whenever they are exposed to open atmospheric air. After a few days or few months, what happens? Automatically, the outer surface of metal will be damaged. That is rusting process we are taking. Okay, so rusting also, are we helping in any way to the iron or to the environment to undergo corrosion process? No. Itself, it is gradually involved in the corrosion process. Such a kind of process is generally considered as spontaneous process. And as we are talking about redox reactions, we can also call them as spontaneous redox reactions. Okay, na? So this reaction is redox or not? Can you tell me once? This reaction is redox or not?
Yes, sir.
Yes, no. Why? Because initially zinc oxidation number is 0, copper is +2. But
Yes.
after the reaction, zinc becomes +2 and copper became 0.
0.
Right, no? So zinc increase in the oxidation number means it is involved in which process, ma? Increase in the oxidation number or loss of electron is called as oxidation process. Very good. That means in this redox reaction, zinc undergoes oxidation. And next, copper is involved in the reduction process. Okay. Now you tell me, in the same example, zinc is acting as reducing agent or oxidizing agent?
Reducing agent.
Very good. It is reducing agent. And copper is obviously acting as an oxidizing agent. Yes, very good. And the last point for today's class, non-spontaneous redox reactions. So it is quite opposite. There, what did I say? There is no external forces required to occur those type of reactions. But in case of non-spontaneous redox reactions, some help or energy source is required. That's why we need to consider some external forces applied, then only the reaction can take place. Okay, then only the reaction can take place. Best example, electrolytic decomposition of water. So water, if you take in the electrolytic cell, and whenever we are connecting it to the battery, because of electrical energy, the water is decomposed to give us hydrogen gas at cathode and oxygen gas at anode. Okay, so here unless we are giving electricity, the reaction may not happen. That's why, since some external force is required in this case, I can say these type of reactions are called as non-spontaneous reactions. And it is also a redox process. That's why it is also called as non-spontaneous redox reactions. Okay, na? Am I clear?
Sir,
Yes, ma'am.
can you give one more example for spontaneous redox reaction?
One more example for
Non-spontaneous reactions.
non-spontaneous redox reaction, right? No? Okay. So you can take like a decomposition of ammonia. Okay, routine examples only I'm giving you. Decomposition of ammonia. Okay, what is ammonia chemical formula? It is NH3.
NH3.
Yes, NH3. So 2 moles of NH3 if I take for the decomposition process, what happens, ma? I'll get 3 moles of H2, balanced equation I'm writing in the elemental form, and 1 mole of nitrogen we will get. Okay. So in the case of ammonia, oxidation number of ammonia if I take, it is -3 initially, and hydrogen is +1. Okay, na? Oxidation number of nitrogen is -3 in ammonia, and hydrogen is +1 in ammonia. After the reaction, if you see, both the elements are converted into elemental form. That means what I can say, hydrogen oxidation number is 0, and even nitrogen oxidation number is 0. Now you compare nitrogen oxidation number from -3 to 0. Increase or decrease, ma?
Increase.
Increase, huh?
Decrease.
Increase, -3 to 0, increase, right? -3 to 0, increase in the oxidation number. So now nitrogen is involved in oxidation, I can say, right or not? Increase in the oxidation number. Okay. Now hydrogen, if I compare, it becomes +1 to 0, decrease in the oxidation number. So it is involved in the reduction process. So now it is the redox reaction, I can confirm. But for this decomposition reaction, definitely some heat energy is required. Okay, unless we are heating that compound strongly, it is not involved in the decomposition process. So that I can say it is also a non-spontaneous redox reaction. Okay, na? So like that, in any case, when external force or external energy is required to happen that particular reaction, those type of reactions are called as non-spontaneous reactions. And themselves, whenever they are occurring in the nature, those are generally considered as spontaneous reactions. Okay, na? Clear?
Yes, sir.
Yes, fine. So I hope you are able to follow and understand what I'm teaching, because we are new to each other, right? Okay, so you did not habituate to my teaching style, and I don't know exactly how you used to listen in the class. So whenever you feel like any query is there or any concern is there, very freely you can express by unmuting, no problem at all, so that ultimately our motto is you should get utmost clarity on the concept by the end of sessions. Okay, na? Yes. So shall we wind up for today?
Yeah. Thank you, Sudhir garu.
Yes, sir. Thank you, sir. Thank you very much. Yeah.
Thank you very much for listening concept. And tomorrow we will meet again. Thank you.
Yes,
Thank
sir.
you very much.
Yes, sir. Thank you.